I'm Allison Jonjak, the Cranberry Outreach Specialist with the University of Wisconsin-Madison Division of Extension. These videos are the on-demand recordings of UW Extension and the Wisconsin State Cranberry Growers Association's virtual Brown Bag Lunch series. These monthly sessions offer growers and researchers a way to share timely and relevant information. We hope you'll enjoy and continue to engage with us.
Hi, everyone. My name is Grant Holly. I'm the Executive Director of the Wisconsin State Cranberry Growers Association. We are very happy to be able to partner with UW Extension to bring you the research needed to be able to navigate our ever-changing environment. I'd like to thank all of our speakers today for their valuable time and leadership, the growers for joining us, and Allison for being the catalyst from which all of these sessions rely.
Good morning, everyone. And right as we cross over into afternoon, I will advance our slides right here through the introduction. And I'm still working on getting the captions to display. As we kind of said, if Microsoft Azure has 2/3 of the airplanes down and our captions aren't working, we're still way ahead of the curve. So I'll get that solved before our speakers are presenting. Wanted to quickly go through our agenda. Steve Vavris is with UW-Madison as well as being the Wisconsin State climatologist, and he's going to give us an overview of the wet weather patterns that we've had thus far this year and a little bit of prospective into the future. Don Valentine since Leslie's unavailable, Don at Oregon State University is going to give some updates on a project that he's working on with Leslie, the same project, and discuss fruit rots and their sensitivities to fungicides. And then we'll wrap up the lunch hour with Jed Cahoon talking about weed growth stages and weed wiping. As usual, if you have questions for clarification during the presentation, feel free to mute yourself and ask, or unmute yourself and ask, or you can use the chat box to ask. If you want to ask anonymously, use the drop down and say your question only to Allison Jonjak, and I'll ask it anonymously on your behalf. If you we'll also have a question and answer session at the end, so feel welcome to use both of those. I am going to, is Grant here to give us a quick hello from the Growers Association? And if Grant is not, I will still at least say, as I'm with the University of Wisconsin-Madison Division of Extension, but this is brought to us both by UW-Madison Division of Extension as well as the Wisconsin State Cranberry Growers Association. So thanks to everyone who supports this and is getting information from here, and we're always welcoming feedback as well. So when I will go ahead and have Don, I presume you'll want to share your screen?
Thank you so much, Allison, and thank you all for having me. I'm excited to talk a bit about our research here on fruit rots on the West Coast. So just a little bit, there we go. Just a little bit background on my time here. I've been part of the Stockwell Lab at the USDA in Corvallis, Oregon for 2 years. And I started right in the middle of a really exciting project surveying cranberry fruit rots in Oregon and Washington fields and testing their sensitivity to site-specific fungicides. And as that project wound down last year, we started along with groups from other major cranberry producing states, including in Wisconsin, this multi-year project. It's called the Systems Approach to Manage the Expression of Cranberry Fruit Rot. But we use the acronym SAME because as scientists, we love acronyms. And there's a few different groups working on this project, and I'm part of pathology, and we are specifically looking at the presence of these cranberry fruit rots at different points in the season to try to ascertain timing of infection. And today I'll be talking about the fruit rots that we're seeing at bloom. And out here in Oregon, at least in Bandon, along the coast, our bloom happens at about mid-June. And before I continue, I do want to point out, if anyone here hasn't signed up for the newsletter, this is a multi-year project. There will be occasional updates going out. So it'll be exciting to see, I hope, what we find. So go ahead and sign up for that newsletter if you'd like. And just to briefly touch on climate, been talked about early season being so wet in Wisconsin. There are some major differences in our West Coast growing states in Washington and Oregon compared to Wisconsin and eastern coast states like New Jersey and Massachusetts. As we can see, the temperatures we have out here are very narrow. We don't get that hot in the summer, and we hardly get below freezing in the winter. This is largely due to that deep Pacific coast shelf bringing up those cool waters to help mitigate temperatures. We have very wet winter and fall, but it dries out quite a bit in the summer. And so, this may account for differences in both the expression of and the types of fruit rots that we see. So just to briefly go over, what's in a rotted berry. There are a lot of potential pathogens, and these here are considered the major ones. But in Oregon and Washington, we've seen all but 2 of these over the last 4 years of surveys, so we'll just take those away. But we do see a significant rot here, Neofibrea, which I'm calling bullseye rot with a question mark because that's what it's causes in apples and pears. We're not quite settled yet on what the best symptomatic term is for it yet, but it's a significant one that we see out here that potentially isn't in other states, and that may have to do with the cooler growing climate. And just, of course, to complicate things further, some of these different rots have multiple species. So with that, what we are looking at is which pathogens infect early in the season. If we can determine this, we can direct fungicide applications to be more effective. And with the same project, we're looking at fungal presence both in and on flowers at around the height of bloom. So we sample these flowers at about 50% bloom, which is mid-June. We take them back to the lab, and with this mighty hammer, we smash them up and then plate them on these V8 plates, as you can see back here. And then we let fungi and bacteria grow out on them. Of course, there's a lot that comes out of these flowers, so we have to do isolations to ID. Here on the left, we see one of our Colototricum species growing over Cladosporium. And here on the right, we've got, I think, 4 different species, one of which is black rot, a noted storage rot. So to date, we have data for 2 years of bloom, and we're largely seeing the same 5 fungi, though their levels can vary drastically year to year. Last year, we saw 1 botrytis isolate out of every 5 flowers we sampled. That's 20%. But this year, there was only 1 for every 50. And for whatever reasons, we did see a lot more of our storage rot, our black rot fungi, and also more Colototricum acutatum. That's one of our bitter rots. So the good news is, if this trend holds across years and states, that we can likely focus management efforts on fewer groups of these fruit rots in the earlier seasons. And since I have it, I do want to show a comparison of these bloom isolates that we saw last year with the isolates we have from our field rots. One thing we see was with the large presence of botrytis in bloom, it did not translate to very many yellow rotted berries. That's caused by botrytis. And we did see about half of these pop up likely later in the season because we don't see them hardly at all at bloom. And with the time remaining, I do want to share some of our results from our fungicide sensitivity screening. We've done quite a bit of work on this over the last few years. And I do want to do just a brief review. The single-site fungicides we're testing are fungicides like Indar, Proline, Abound. They're more targeted in their action against fungi, and they are less detrimental to other organisms as opposed to multi-site fungicides like Bravo or Mancozeb. The trade-off, though, is that resistance to single-site fungicides is much more likely to develop than with multi-site usage, especially when they're overused or not rotated with other single-site fungicides. So we're working to establish a baseline of sensitivities for these fruit rots and also screen for potential developing resistance. And largely, we are seeing a consistency with sensitivity based on either the group of fruit rot or more specifically, the different species within those groups. There is some variability yet to be explained, but we'll get into that here in a sec. So just a little background on the fungicide tests that we do. We take varying concentrations of each fungicide, including a control without fungicide, and grow these pathogens on the plates to assess their sensitivity. Now, to streamline this process, we've landed on a specific concentration that is informative of each pathogen's sensitivity to each fungicide. This saves immense time and resources. Because of that, to date, we have screened over 600 isolates to 3 commonly used single-site fungicides. And so, of course, even in a simplified table here, there's a lot going on. So I'll zoom into a couple examples here. But these are our 3 fungicides we've been testing, 2 FRAC-3s, fenbuconazole and prothioconazole, which have similar chemistries, and then our FRAC-11, which is azoxystrobin. We see in the green these rots that have a higher sensitivity to the specific fungicides, and as they get closer to orange, they're much more tolerant. So we're going to zoom in here on Coleophoma. This is our ripe rot fungi. This is one that I think we see more often later in the season. And so here we are seeing the results of 107 Coleophoma isolates and their growth on these 3 fungicides compared to growth without. So while Coleophoma seems relatively sensitive to both FRAC-3 fungicides, near universally, it appears to be rather resistant to azoxystrobin. This suggests, a baseline of sensitivity, and that if a field had high pressure of rot from Coleophoma, our FRAC-3 toolbox is going to be much more effective than an application of FRAC-11. Next, we'll look a little bit at our Diaportha, a bit more sensitive to our FRAC-3s, but with some variability in the FRAC-11. So here we see most of these isolates do get knocked down to no growth in the presence of both of these FRAC-3s. But with the FRAC-11, we see a wide range of results. And so this last year, we took all of our Diaportha isolates and sequenced them to ID them to species. And what we found was that we could explain at least some of the sensitivities of these different species to their specific species. There's still more going on to explain, why some of these are so resistant while others are not. Lastly, we'll get into Colletotricum. This is one of the most major of fruit rots generally. Causes our bitter rots, tend to cause kind of wrinkling and yellowing of berries. And it's caused by 2 different complexes. And within each of those complexes are multiple species. So it does get a little complicated, but they all cause essentially the same type of fruit rot. So here we're looking at one specific Colletotricum. This is Gliosporoides. And we see something a bit different here for our FRAC-11. The Gliosporoides seem to have a moderate sensitivity. But when we look at our FRAC-3s, there is a sensitivity to one of them, prothioconazole, and a high resistance to fenbuconazole. And this actually meshes with some field data published a few years ago, I believe from Wisconsin actually, that showed that these two fungicides were effective at controlling Colototricum gliosporoides, whereas fenbuconazole was not. So it's nice to see there's some correlation between when we're simplifying things in the lab and then when we look at how these fungi react to fungicides out in the field. And so just to recap, it is complicated. There's quite a few fruit rots with varying sensitivities to these single-site fungicides, though at least for our Oregon and Washington isolates, these sensitivities appear largely dependent upon the complex or species, not necessarily from acquired resistance. And we are seeing relatively consistent species at bloom, though the levels of each seem rather dynamic. And this is good news because it can help direct more effective fungicide applications. And potentially for our organic growers, we may be able to target more relevant biocontrols which inhibit and outcompete the specific pathogens we see early in the season, rather than trying to focus on biocontrol activity against all cranberry fruit rots. And with that, I can take any questions.
Thank you very much. We do have, again, a couple of minutes for questions here. I really admired those, kind of green to orange scale. Here's where we see not a lot of resistance. Here's where we see a lot of resistance. So those are very helpful slides for me to see broken out pathogen by pathogen. Happy to take any questions here. While we pause and wait for questions, I will also activate the poll. I made a poll that is in 2 parts. It is fully anonymous. So I'm going to ask that Wisconsin growers respond to this. So if you're an Oregon grower, do not participate in this poll. So I've got questions up. Have you noticed reduced yield potential because of a wet pollination season? I have options for significantly reduced yield potential and probably because of the wet pollination, slightly reduced yield potential, probably because of the wet pollination, significantly or slightly reduced yield potentials, but not really certain that it was pollination or not certain of the cause. And then a final option for my yield potential is not reduced. I have then a multiple choice question for the second one. So if you use honeybees and bumblebees and native pollinators, please check all 3 of those. We are have a lot of answers still to come in as we are showing the kind of first batch of people. It looks like no one is feeling no one is not certain of the cause. People that tend to have pollination related yield reduction, it seems to be largely in that slightly reduced category. Of course, those are subjective. I do have about 60% of the call has responded now. I'm actually going to, I've realized that these poll questions don't display when I display the answers. So I'm going to paste them into my PowerPoint so that you can see them. And so I'm going to finalize this poll and then share my screen so that you all can see the results of these. I was hoping that it would pair the answers while leaving you anonymous. It looks like we almost got that far. So share screen, my PowerPoint. And so then I'm going to bounce back into full screen mode and review these results in which we had 1 out of 15 had significantly reduced yield potential that was probably wet pollination related. More than half of Wisconsin grower respondents noticed slightly reduced yield potentials that are probably wet pollination related. 5 of our growers, or just over a third, don't see a reduced yield potential, and then 7% of Wisconsin growers here have a significantly or slightly reduced yield potentials, but not certain of the cause. In terms of pollinators, I was hoping these would be paired, and if I'm able to tease that information out later, I'll follow up in an email to those who were on this call here, but 100% using honeybees, as well as just about half using bumblebees, as well as about 67% using native pollinators. So those are our stats for that. I have Jed up next, but I'm going to check whether we have any other questions that have come in during that time. We have about 1 minute left if there are any other questions. Otherwise, I want to thank Steve, as well as Don, as well as Jed, for giving us these great in-season updates, and anyone having any follow-up questions, feel free to reach out. Otherwise, we're going to look forward to seeing you at the summer field day in August 14th at Cutler, Cranberry, and City Point. Last minute for any questions. Thank you all for joining today.